Hello viewers, I am Kausalya. Today we are going to see problem number 3 in time response analysis. The problem is measurements conducted on a servo mechanism show the system response to be C of t is equal to some expression is given. This is your output response of a system. When subject to an unit step input, and the type of input is unit step input. Obtain an expression for the closed loop transfer function. Determine the undamped natural frequency and damping ratio. Right. So here our final output response is given and the type of input here is step input. With these data, we are asked to find the expression for closed loop transfer function, and with that closed loop transfer function, we are asked to find what is the undamped natural frequency and damping ratio, right? So, the solution starts here. So, this is our given expression, right? So, the first step is we are asked to find closed loop transfer function. So, in order to get closed loop transfer function, what is the general format of closed loop transfer function? It is C of S by R of S, that is output by input. So, here I am taking Laplace transformation. So, when you take Laplace transformation for this expression, C of t becomes C of S, 1 becomes 1 by S, and here this 0.2, it is a constant, so 0.2 remains as such, and e power minus 60t. So the basic formula is e power minus at. When you take Laplace transformation for this expression, the answer is 1 by s plus a, right? Using this formula here, e power minus 60 is written as 1 by s plus 60. And similarly here minus 1.2, this remains as such, and e power minus 10t, when you take Laplace transformation, that becomes 1 by s plus 10, right? The next step is we are going to take LCM. So here we are having three different terms. So s plus 60 and s plus 10. So as you take LCM here, s is already present. So we have to multiply this one with these two terms. So s plus 60 into s plus 10. And similarly plus 0.2, and here I am having s plus 60, right? So the remaining terms are s into s plus 10. And finally minus 1.2 into s plus 60. The entire term divided by s into s plus 60 into s plus 10, right? Now we are going to multiply and simplify this expression. So here just consider these two terms initially. So s into s becomes s square and s into 10 becomes 10s. And next 60 into s becomes 60s and 60 into 10 becomes 600, right? And next consider this second expression. So 0.2 s into s becomes 0.2 s square and 0.2 s into 10 becomes 2s, right? Minus again 1.2 s into s becomes 1.2 s square and minus 1.2 s into 60 becomes 72. So minus 72s, right? The next step is I am going to combine all the s square terms, all the s terms and all the constant terms. So here s square here, that is 10s plus 60s becomes 70s and this 600 as such. And here the remaining terms remain the same. The next thing is I am going to combine s square term, s term and constant term. So here s square and here 0.2 s square. So 1 s square plus 0.2 s square becomes 1.2 s square. And here 70s and here 2s. So plus 72s plus 600. The remaining terms are minus 1.2 s square minus 72s. Here 1.2 s square and minus 1.2 s square cancel, and similarly 72s and minus 72s cancel each other. And finally the expression will be having 600 divided by s into s plus 60 into s plus 10, and this is nothing but this is our C of s, right? The next thing is, So this is our expression. C of s is equal to R of s into, that is 1 by s into 600 by s plus 60 into s plus 10. So this 1 by s can be written as that because in the problem the input is unit step. So for unit step input, that is expressed as 1 by s, right? So here R of s is the input. So in the place of 1 by s, I am writing R of s. The remaining terms as such, 600 by s plus 60 into s plus 10. So what is the general form of representing a second order equation? It is C of s by R of s. So here I am bringing this R of s to the denominator part. So the expression is like this. Okay, 600 divided by the remaining term. Here I am multiplying these two terms. S into s becomes s square. 60 into s becomes 60s. Next thing is 10 into s becomes 10s and 10 into 60 becomes 600. So when you simplify, you are getting expression like this, right? So this is our second order transfer function. Now I am going to compare this one with the standard form of the representation. So in the place of omega n square, I am having 600. So equate these two things. Omega n square equal to 600. So omega n is nothing but square root of 600. And finally the answer is 24.49. Okay, since it is a frequency, I am representing it as radians per second. And the next thing is I am going to compare this expression with this one. So 2 zeta omega n is equal to 70 here. So omega n we know 24.49. So just substitute the values here. And when you rearrange, finally the answer is zeta equal to 1.43. Okay, that's all. The problem gets over here. Hope you people understand well. Thank you.